Welcome guys, this is logarithm week 3 for ss3. Now we're going to look at this. We are going to go in deep in logarithm. So at the end of the at the end of this lesson, you understand how logarithm works, everything on logarithm. So let's look at the content of logarithm, content of this particular course. Now this is our learning objective: logarithm of numbers, how you can convert from logarithm to index form to logarithm. Then laws of logarithm, we are going to look at it one after the other. Then we'll look at each of the laws. Then I'm gonna explain how those laws work. Logarithmic equation, is it all the fact this logarithm is core concepts of ss3 mathematics that you have to know. And the logarithm is started from ss1, logarithm of number less than 1. From ss2 you did logarithm of number greater than 1, which I taught in our previous class. Then this one now is when you are looking at logarithm and other form, how it works. By the end of the course, you'll be very good at solving problems on logarithm. So let's move on. Now we want to look at conversion of indices to logarithm. What is the answer of this? Now the answer of this is for you to understand how you can make a number in either in logarithm form to indices form. Then it will be easier for you to solve it, even without having an understanding of the laws of indices. With this background of conversion from indices to logarithm and logarithm to indices, you'll be able to solve any logarithmic question. Now let's look at this question. And they said the first one, you convert it to logarithm form. The answer is that sometimes they will give you in logarithm form. If you can convert it to index form, then it will be easier for you to solve the question. Now they are giving you in index form, you have to convert it to logarithm form. Let's look at that number one. Let's look at number one. Sorry for the delay. Sorry. Okay. Now number one. Now you have 2 raised to the power 6. This is what they gave us. 2 raised to the power of what? Of 6 equals to 64. Now if you want to convert this into logarithm form, the one that does not have a power, you add log to it. Between these two, this one has a power. This is the power, a index. So it means this one you add log to it. This will be log. You can bring it to the other side, no problem. Log 64. Now is equals to, you see these two that is here, you bring it at the bottom here. The 6 will stand alone. It means the 6 at the top of this space will be here. These two these two base will be under here. That is it. You can see the logic. It's very simple. Now look at the second one. Let's look at the second one. You can do the second one by yourself. Which one is going to we're going to attach log to? We are going to attach, because this is what we are given. 25 1 over 2 equals to 5. So we are going to attach log to the one that does not have logarithm, that does not have indices, that does not have an index. So it's going to be log, as number standing alone, log 5. And I told you that what is there, this base here, you're going to bring it here. Then the index here, this 1 over 2 is going to stand alone, 1 over 2. So that is it. Now the third one, you have 4 raised to the power minus 4 equals to 1 over 2, 5, 6. This one is not in index form, so you are going to add log to it. This will be log 1 over 2, 5, 6. And I told you this base here is going to come here. Then the power is going to stand in low, minus 4. And last one now, let's look at the last one. You have log 1, 49 raised to the power 0. So the fourth one, we have 1 equals to 49 raised to the power 0. Which one does not have indices, does not have power at the top? Indices, this one. So you put log, add log to it, log 1. This power, this base here, we are going to put it at the owner of this space. Then everything is equals to, the power is going to be equals to 0. So this is how to convert from index form to logarithm form. So let's move on to the next one, conversion from what? From logarithm form to index form. Let's move on. Now we're going to look at conversion of logarithm to indices. Now the inverse of what we did earlier. Now let's move on. Now this is the question given. You are given a logarithm form that asks you to convert to index form. This is log base 2, 128 is equals to 7. Now what you're going to do is that this is what you are given. So this one, you are given log base 2 128 equals to 7. What you are going to do here is that you remove this log. This 128 is going to stand alone, so it's going to stand alone. Now this 2 will cancel, you become base, this one will become power. It means this 2 will now become big 2, then this 7 will become the power. That is it. Look at that number 2. Number 2, which is b, you have log base 10, you have 0.01 equals to 2. The same thing, it means this one is going to stand alone. You have 0.01 equals to, this 10 will now come here, then this will become what? Sorry, this one is minus 2, and this base, this one here will now become power. You do understand that? So let's look at number 3. You have log 1.5, then 2, sorry, you have 2.25 equals to 2. Now the same thing you are going to do, this one here, because the big one is going to stand alone, 2.25 equals to, this one will now come here, you become base. Now this one here will now become the power. That's how you're going to solve that. Now let's look at the last one. The last one we have, which is 4, we have log base 1 over 2, then you have 1 over 4 equals to 2. And I said this one here is going to stand alone, so it's going to be 1 over 4 equals to, this one at the bottom here, base there, is going to stand as big one, like 1 over 2. Then this one that is there is equal, the other side, the left side is going to become the power. So I'm going to put in the bracket, so it's going to become power. So this is your final answer. So when you check very well, you can see 1 squared is 1, 2 squared is 4, 1 over 4, 1 over 4. They must be the same thing. The multiplication of the first and the left side will give us the same thing. So let's move on. Now we're moving to laws of logarithm, and I'm going to go over those laws one after the other. So at the end of the day, you understand how those laws work and how you can apply it in solving logarithmic question. Now this is the laws here. The laws are here. The first one, product laws. When you multiply two numbers together, its terms are saying when you add them together. So what are they saying here in the first law? This is what we are giving in the first law. Let me write it here so that you can see what I'm saying. Now it says that when you have log a x y is the same as saying log a x plus log a y. Now this thing, they are equivalent. It means if you are given in this form, you can transcribe it to this form. If you are given in this form, you can transcribe to this form. For example, if somebody said you should solve this, said you should simplify. Let's assume you are given something, said you should simplify. You are given log, let's say log 2 base 8, log base 2 8. Let's say plus log base 2, let's say 4. You are given something like this. You have to simplify it to find the answer. Now you are going to apply the laws of logarithm. And laws of logarithm say what? For plus, you are going to what? Multiply. It means they have the same base. You pick one of them. That will be log what? Log what? Log 2, because they have the same base. Then you now multiply, because of plus is said what you can multiply. That will be 8 times 4. So here we have log 2 32. Now you want to get the final answer. Though there are ways you can do this thing. There are ways you can do it. We are still going in there. One of the laws are here. But the way you can do it is that you can translate this thing into indices form. You now use that experience with the previous note to know how you're going to do this. It means we also, what is the final answer for this? That I don't know the answer. Just say x, I don't know. So you have to look for this x. Now I told you that this 2 will come here, this will become base, this will become power, this one will stand alone. So you have 32 equals to 2 raised to the power of what? the power of what? Of x. And in indices, I told that you must make them the same number or the same power. So I can do this one as saying 2 raised power what? 5 equals to 2 raised power what? 2 raised power x. So 2 can cancel 2. So x equals to 5. It means log base 232 will give me, my answer is what? Is 5. It means the answer for this one is equals to what? Equals to 5. So that is that under the first rule. Now let's move on to the second rule. The second rule is division. Let me clean this. So the second rule is division. Just hope this thing is, I don't want to waste my time and your time. Okay, since the second rule is division, so let's look at the division part. Now division is just like, the other one is just like when you what? That minus, when you divide, when you have log, this second law, log what? A, you have x over y. They said it's the same thing as saying log a x minus log a y. It means when you have subtraction in between logarithm, you can translate it. Given division, you can turn it back to what? To subtraction. For example, if someone gives you something like they said log, you should look for this log, let's say 2, and you have, let's say you have let's say you have 64 over 4. Now they ask to do this thing. If you want to do this now, it's very easy. You can just use it like this. So let's split them together. So we have log what? Log 2, or let's say you are given a minus. Sorry, I don't want to use this. You can transcribe, but based on what is given here, let's look at the rules there. Though you can do it like that, but I just want you to understand how it works so that you know, be confused on what to do. Now I'll make it in minus, in negative sign, so that you can understand. So let's assume you are given, you have log, let me use 3 now, log 327 minus log 3, let's say 9. Now in this, this thing here, you have to turn this back to what is there. So I can say that because both don't have the same log, they have the same base as a log, I can pick one of them, log 3, then I'll now use my rules. This one will be what? The minus is division, it means I'll turn to 27 over 9. And 9 here is what? 1. 9 in 27, 9 times 3 is what? Is 27. So here you have what? Log 3, log base 3, base 3. Now in this now, that go back to that now leads to another rules of the law. It means if what is the base is the same thing what is here with what is here, the base and the number given is the same thing, you are going to turn it to 1. It means everything here is going to become what? Is going to become 1. Is equals to what? 1. If I give you log base 10, it is 1. If I give you log base 100 equals to what? Is equals to 1. So that is how that one works. I think that is a log one of the log here. I think is this one here. Yeah, this one log AA. So I've done that one. I won't go back to that one again. So that is for division law. Now let's now move on. Let's say you are given another one. Let's look at the third one. I'm going to be fast because I'm not going to look at everything. As you continue solving, you look at complex question, then you now understand when you have to use those laws. When is those laws, when what, how what you have to apply is, because that is the main thing. How to apply laws of what? Laws of logarithm based on the question you are given. Now you have another one that said you have log what? Log base a x what? Xn equals to n log a what? Ax. Now what this one is saying is that if you are given something like, let's say you have log what? Log 3 raised power what? 3 raised power of 2. Look at it now. It means I can bring this 2, you can bring it to the front. So it means this thing can change to bring this 2 to the front to be 2 log what? Log 3. And I told you log 3 is what? Is 1. So this thing here is times now. So it will be what? 2 times 1, which is what? Which is 2. It's not a must, it must be the same thing. Sometimes they'll give you like this. If they give you log what? Log 2, 4 raised power what? 4 raised power of 3. You can bring this 3 to the front. There will be 3 log what? Log 2, then what? Then 4, right? Look at that thing again. Now, I can still change this thing. This can give me 2 raised power 2. So I can even do like this again. 3 log. You can see logarithm is very straight. 2. Then 2 raised to power 2 is what? Is 4. 2 raised to power what? 2 raised to power 2. It means this one also will come to the front again. It will multiply what is here. So I'll now have 2 times 3 log what? Log 2, 2. And 2 times 3 is what? It is what? It is 6. And I told that log 2, 2. Anytime you have the base and the part the same thing, it should be 1. So this will be times what? Times 1. Which your answer is what? Is 6. So that is what for that one. So let's move on to the next one. The next one, let's look at it together. Let's look at another one. It means what they are saying here is, let me just look at another one. Let's say we have log, they gave us log what? Log A, then you have B, base B. They say it's the same thing as saying, you know what's at the base? There must be something at this base here. Probably let's say you have like base 10 or base 2. Let's say you have this one here, C. There's a C here. Just like having, let's say, okay, now it means you can split them. There can be this thing can be log what? Log what? Log this will be log base C, then B over what? Log what? Log what? C, then what? Then A. It means if I give something, let's assume I give something like this, you have log, let's say you have log, let me just say you have log 2 raised to power of, let's say 2 raised to power of 4. Then another one we have log 2 raised to power of what? Raised to power of 3. Look at this. So it means this thing you can turn into, it can be, since you have, it can be log what? Log what? Because both of them have the same what? The same base. So it can be log what? Log 2, 3 over what? Log what? Log 2, then what? Then 4. So this can cancel this. So your final answer can be what? 3 over what? 3 over 4. So that is what that log is talking about. We are still going to look at question under it, how you can apply this particular thing under what? In logarithmic question. And then let me was the first one that they gave you. So I told you how to solve log A and B and so on and so what and so forth. So another one, let's look at this one. Let me look at the fourth one. The other one is derivation of the laws there, and I've derived one of them. That one that have base and power, the same thing. Now in this one they give us, let's assume you are given something like this, log what? They say log what? Log base A B. The same thing as saying 1 over what? Log 1 over log what? Log B what? B A. So what you are saying here is that if you have log what? If you have log base 2, let's say base 2 8, you can do it again as saying 1 over log what? Log. So this B, this one here, it will be your what? Your 8, and this one will become your what? Your 2. It's the same thing. It means you know that this is just like inverse. What you get here is what you get here. It's still the same thing. So you're going to get the same answer. So that is what that one means. So let's now move on to questions under laws of logarithm and how you can apply those laws on those particular questions. So let's move on. Now I want to look at applying those laws we've talked about to solve logarithm question. Now let's assume we are given a question like this. Let's assume that they give some condition that you should solve this. We have log base 10, log base 10 root 35 plus log base 10 root 2 minus log base 10 root 7. They ask us to solve this thing. How do you go about it? You are going to apply the laws of logarithm. You know plus is what? Plus is times, and minus is what? Minus is division. It means multiply this by this and divide it by what? Divide it by this. All of them have log 10, log 10, log 10. So you bring 1 out of them. So you are going to have root 35 times what? Times root what? Root 2. Then division, sorry, divided by what? Divided by root what? Root 7. Did you understand that? So it now goes to now log what? Log 10 root 35 times root 2. Laws of sod. So that will give us root what? Root 70. all over what? Root 7. I can divide this thing. It's possible. But normally in sort, this is what you do. You rationalize to be root 70 times. You use what's at the bottom to multiply the up and down. That is root what? Root 7 over what? Root 7. We still get the same thing. I'm just showing you normal way of doing this thing. So this times this will give us root 240. 7 times 7, that is 490. Then with 7 times root 7 will give us what? Will give us 7. So this one, making it in sort basic form, you have 7 root what? Root 10 all over what? 7. So 7 cancels 7. So your answer is root what? Root 10. So if I want to go straight here, I can just say root 7 here 1, root 7 here, it is what? Root 10. I can do it like that. So I have log 10 root what? Root 10, right? This root 10 now, I can rewrite it as saying log 10 1 over 2. I can do that. If it means if you are given root 5, you can rewrite it in index form as saying 5 1 over 2. If you are given root 8, you can write it as saying 8 1 over 2. Let's assume now you are given root let's say cube root of let's say 25. You can write this now as saying 25. This one is 3, it will be 1 over 3. So get the logic right. Now in this one now, it means now you apply the laws of logarithm. You bring this 1 over 2 to the front, right? I told you that will be 1 over 2 log what? Log base 10, then 10. 10 base 10, 10 is what? Is 1. That is 1 over 2 times 1. So your final answer is what? 1 over 2. So this is the answer for this one. You can copy this down. Now let's move on. Now let's assume we are given another one. We have okay, you have log, you are given log root 8 over what? Log what? Log 8. Now you can do this division in minus, then apply the laws, but I'll show you the best way of doing this thing. So in this one, I told you that you can write this thing as saying log 8 1 over 2. Am I not right? I'm right. Sorry, this one is not base, it is a whole number. Sorry for this. So here you have log what? Log 8, then you have 1 over 2 over what? Over log 8. Now my students always do that, they pam they will divide. Don't do that. You can change this one to index form. So I will have log 2 raised power 3, then I still have 1 over 2 at the top, all over this one at the bottom can also be what? Log 2 raised power of 3. Now I can bring this one, bring it to the front to make it easier for me. 1 over 2 log 2 raised power 3 over log what? Log 2 raised power what? Raised power of 3. Do you get the logic? Because sometimes this one, what if it's now 4? So how are you going to go about it? Now I can make it easier for myself. I can bring this 3, I can still use this 3 to multiply what is there. So it will be 3 times 1 over 2, right? Log, now I have log what? Log 2 over the other one. This 3 will come to the front here. That will be 3 times log what? Log 2. So this log 2 can cancel this log 2. 3 times 1 over 2, that is 3 over what? 3 over 2 divided by, this means over, divided by 3. That will be 3 over 2 times, this one is over 1. This one will come up, this one will come down. That is 1 over 3. 3 here, 1, 3 here, 1. So my answer is what? 1 over 2. Can do the log 8 and log 8, you can divide that also, but this is the best way of doing it to give you a broad mind of how to solve this question. Now let's move on to the next one. Let's assume we are given something like this. We have log roots 27 over log 81. So how do you solve this? The same thing, you can rewrite this thing as saying log 27 then 1 over 2. Am I not right? Over what? Log 81. Now what I'm going to do is that you bring this one to the front now. So I want to take it step after step so that you won't make mistake. Log what? Log 27 over what? Log what? Log 81. Now there's a way you can do this. No, 3 raised to power 3 is 27, 3 raised to power 4 is 81. Now the other one, because it's log 8, you can cancel, but this one you cannot cancel. So I can rewrite this thing as saying 1 over 2 log. Now I have what? 3 raised to power of what? Raised to power of 3 over log 3 raised to power what? Raised to power of 4. So I can use this 3 to multiply what is here, because it's power. That will be 3 times 1 over 2 log what? Log 3 over then 4 times log what? Log 3. Because this 4 here it's come to the front. It's come to the front. So this log 3 can cancel this log 3. 3 times 1 is what? Is 3. This 3 over 2. 3 over 2 divided by 4 over 1. Because of this 4. This 4 is 4 over 1. So we have 3 over 2 times, this one will come up, this one will come down. This 1, sorry, is 1 over 4. So 3 times 1 is 3, 2 times 4 is 8. So your final answer is what? 3 over 8. So that is your final answer. So this is it for the other one. So let's move on. Let's look at another question. Let's look at more complex question. Let's assume we are given something like this: log 3 13.5 minus log what? Log 3 10.5. Now working with decimal point is always problem. So what you do is that you convert this one to you convert it to fraction, and 13.5 to fraction, it means we just move once, right? That will be what? 135 over 10. Right? So it means what is there will be log what? Log 3. That will be 135 over what? Over 10 minus log what? Log 3. Now this one here is also 1. You can't remove 10.5. Then you move once 1. So it's going to be 10 at the bottom. 105 over 10. So this will be 105 over what? Over 10. Now what we are going to do is, let's divide. 5 here is 2. 5 in 135. 5 in 13 is 2. Remember 3. This is 27. Then here, so this one is over 10. There's a mistake. Over 10, right? 5 here is what? Is 2. 5 here is what? 5 in 10 is 2. This is 21 over 2. So we have log what? Log 3 27. Is it 27? Yeah, 5 in 10 is 2. 5 times that is 27. 27 over what? Over 2 minus what? Log what? Log 2. Log 3, sorry. Log 3, 21 over 2. Now in this one, I apply the laws of logarithm. You know, this is going to be what? Division, right? So they have the same law, log 3, log 3. So you can pick up the log 3, log what? Log 3. That will be now be 27 over 2. Are you following what I'm doing? I hope you are following. Please follow. Just calm down. Divided by 21 over 2. So I can write this thing as saying, log what? Log base 3, 27 over 2. Division is, you turn the division to times. This will go up, this will come down. 2 over 21. So 2 here is 1, 2 here is 1. 3 in 27 is 9. 3 times 9 is 27. 3 in 21 is what? Is 7. So you have log log what? Log base 3. Then you have 9 over 7. Now you can now change it back to that. No, those things are interwoven. You can change this 9 over 7 back to what? Back to negative. They are interwoven. You can return it back to the former, the previous work. So it can be log what? Log 3, 9, right? Equals to, no mistake, minus, this will be minus log what? Log 3, 7. So I can find the answer for this one first. So log, this one will log what? Log 3, applying the laws of logarithm, log 3 raised to power 2, right? 3 raised to power 2 is 9 minus log what? Log 3, 7. And these 2 can come to the front, so I will have 2 log 3, 3 minus log 3, 7, right? 3, 3 is what? I told that log 3 and base, if it's based on the same thing, that is equal to 1. That is 2 times 1 is 2. This will be 2 minus, so yay, what is this? That will be 2 minus log what? Log 3, 7. So this is your final answer. So that is that for this one. You can what? You can pause the video, copy it, or do it on your own. You will get it. Mathematics is an art. You continue practicing. At the end of the day, you discover that what? It is simple. It just what? It's phobia that makes students fail mathematics. Now let's look at another one. I'm going to look at more complex one. Now you have something like this. They give you something like this, log base 5. You have 3 over 5. This is what they gave you, plus 3 log, you have base 5, then you have 15 over 2, then they'll give you minus log 5, then you have 81 over 8. So how do you solve this? Now what I'm going to do is that this is what I like doing. I can make this 3 to the front. Let's make everything the same fraction. So I can say log 5, 3 over 5, log base 5, sorry, plus this 3 I can bring to the front. If I bring to the front, it becomes something like this. It becomes power. Am I not right? I'm right. So this will be log what? Log 5. So this 3 raised power 15 raised power 3. That will give us what? 15 times 15 times 15. 15 in 3 places. That is 15 times 15 times 15. So let's check. If you have your calculator, times 15. That will give us 3,375. This is 3,375. Right? Over what? Over 2 raised power 3 is 2 times 2 times 2 times 2, that is 8. You can see now it's changing now. Minus log what? Log base 5, 81 over what? Over 8. Now you can now apply the laws of logarithm. Now log 5 is in everything. So I can say log base 5, and I say 3 over 5 plus is times, then what? 3, 3, 7, 5 over 8. The minus is division, divided by 81 over 8. So this one will now give me now. Now I have to change the division to times. So I have what? Log base 5, 3 over 5 times 3, 3, 7, 5 over 8 times, this one will go up, this will come down, 8 over 81. If you know you are not good at dividing like this, you can multiply everything here together, multiply what's at the bottom together, then divide it by each other. But here I can do it on my own. I can say 8 here is 1, 8 here is what? Is 1. Can 81 goes in 3,375? Let's check. It cannot go. So 5 should be able to go here. 5 here is 1. 5 in 3,375. 3,375 divided by 5. That is 675. This one is 675. Now 3 here is 1. 3 in 81. 3 times 3 in 81 should give us 27. I think if I'm right, that is 27. Now let's check. Can 27 go in this? Now 675 divided by 27. Let me check. It can go. That is 27 here is what? Is 1. And 27 here is what? Is 25. This look rough, but believe me, when you multiply the up number together, get the answer, over multiply the bottom number together, get the answer, then divide it, you still get what? 25. So we have log what? Log 525, right? No, you have to turn this 5 to what? To index form. That will be log what? Log 5. 5 is power what? 5 is power of 2. Then what do you do now? You're going to what? You bring the what? You bring the 2 to the front. So that will be what? 2. Then log what? Log 5, 5. And log 5 is 1. That is 2 times what? 2 times what? 2 times 1. Which is your final answer is what? Is 2. So this is it. You can check for yourself. Look at it. You can see what is very simple. Now let's move on to the next one. Now let's assume we are given something like this. let's assume we're given something like this. You have this will be the last one. We have done lot. Let's say you have 1 over 2, then you have log 4, then you have 8 here. Let's do something like this, plus log what? You have log base 4 32 minus log what? Log base 4 2. So how do you solve something like this? Applying the laws of logarithm, right? I can bring this 1 over 2, bring it here, becomes the square root. Yes, I can do it. It's possible. So I will have log 4, this 8, 1 over 2. It's possible now. Plus what? Log 4 32 minus log what? Log 4 2. Log 4 2. Now what is happening here is that in this one, this is square root. I can rewrite this as saying log 4 square root of 8. But if you know what you are doing, you can find the answer for each of them, then minus the final answer. But I'm just doing it the best way that you can understand. Plus what? Log 4 32 minus what? Minus log what? Log 4 2. Now, what you're going to do, applying the laws of logarithm, you multiply this one and this one together. So you pick the log, so you divide it by the answer of this. So they are log 4, log 4, log 4. So I'll pick log 4 out. Log 4 out. That will now be root what? Root 8 plus is times what? Times 32 all over what? All over 2. Is that not clear? So 2 here is 1. 2 in 32 is 16. Right? So I have log 4. So we have what? Root 8 times 16. Don't worry about this log, this root something. We're still going to look at surd in our next class. So but let's just look at this. So this one, 16 times root 8 will give me what? 16 root 8. That is log what? Log 4 16 root what? Root 8, right? Now root 8 is 2 root 2. It means just don't be scared. Don't worry. You're still going to get this thing. Let me make it easier for you. So 16 root 8 means a perfect square. 4 times 2. 4 times 2 is 8. Root 4, it is 2. So that this one will become ordinary 2. Now multiply what is here. So you have log what? Log 4 32 root what? Root 2. Did you understand that now? Because this one is becomes 2. 2 times 16 is 32. Then this root 2 is, you can't get the final answer. So this root 2, you know this 32 root 2 now. So I can do like this. I can say log log base 4. So this 32 root 2 now, how can I do this thing? How can I make it easier for myself? Now it is same as saying 32 times what? I think 1 over 2, if I'm not mistaken. Right, that is this one. So I can still go further, trying to check how we can solve this thing now. Now this is 32 root 2. 32 root 2. Let's see what we can do here. Now what you're going to do now is you are going to remove this. Now you are going to what? You are going to convert this thing. If I want to make it easier for myself, I don't want to go through this stress again. So let's look at it. So you are going to, let me clean this one here. I try to figure out the best way of doing this thing instead of going through that stress of multiplying by this. Let me clean this off. This one to looks a little bit complex, but by the time you start doing sort, you understand, and you come back to this place, you understand. Now what I'm going to do here is that I will convert this thing back to ordinary form. That is in sort, I'll convert it to ordinary form. This thing, this number here, I'll convert it to ordinary form. So what I'm going to do now is that I can change this one here to ordinary form. It means 32 squared. It will be, to change this one to ordinary sort form, it will be root, sorry, this is wrong with my pen, sorry. So there will be what? 32, this problem, 32 squared, times what? Times 2. So 32 squared, when you check 32 squared, 32 squared will give us, that is 32 times 32. That is 1024. And 1024 times 2, that will give us, times 2, that is 2048. It means everything here is 2048. It's working with 2048. Oh my god, 2048. It's just, sorry for all this. 2048. So let me just clean this one so that hope you can understand all this one I did here. Let me clean this. This is a little bit, it looks tricky, but it's very simple if you know how to go about it. Now, what we're going to do now is that now what I have is, this is the last one. I want to start giving us problem. Now, what I have what? Log 4 root 2048. This is what I have. 2048. Now, what I'm going to do is that, you see this 4, I can change this. Okay, I don't know the answer. Like I told you earlier, I can change it to index form. So it means this 4 will become 4 raised power s, then this one will stand alone. So you have, I cannot change this one. So I have 2, so 2048 square root of it equals to what? Then this 4 will come here, 4 raised power of what? 4 raised power of what? Of x. So this is a long method of doing this thing, but there's a shorter method. If you can get the shorter method, no problem. Now it's just the way it is. So let's look at it together. So I cannot change this thing. I can change this thing to roots. So I can turn it to something like this: 2048, then 1 over 2. I can do something like this. I thought that this square root means 1 over 2 equals to 4 raised power of what? 4 raised power of x. So sorry for this. Now what we are going to do now is, now this one here I can make it 2 raised power what argument to that will give me 4 over 2048, then 2 raised power of, I think 2 raised power of 11, which should give us 2048. That's 2 raised power of what? Of 11. Then you have 1 over 2 here also, which we are going to use to multiply. Then this one will be what? 2 raised power 2 will give us 4. 2 raised power 2. Then you have what? You have x here also, right? Now this 2 can cancel out this 2. 11 times 1 over 2 is what? 11 over 2 equals to, there's equals to here. This one is equals to 2 times s is what? Is 2x, right? Now 2x. Now, so we are going to what? Divide both side by what? Divide both side by 2. Let me clean this one here. Or should I scroll down? No, I think there's no. Let me scroll up so you can do it. Pardon me for this. So we have here, you have let's check the bottom. We have 11 over 2 is equals to 2x. So here we have 11 over 2 equals to 2x. Now I'm going to divide both sides by what? I cross multiply. So I cross this over 1. So if I cross multiply, that will be 11 equals to what? 4x. So I will divide both sides by what? Both sides by 4. Both sides by 4 to make s stand alone. So 4 cancel what? 4 cancel 4. So it means my final answer is what? 11 over 4. So I think this one is to give us a little bit of problem, but at the end of the day, we solved it. That solved form may be very complex for you in solving, but as the next lesson will be on solved, then you understand how I got that answer. So let's move on. Now we are going to look at solving log with a given value. Now take for instance, look at this question. They said, given that log 10 5 is equal to 0.699, log base 10 3 is equal to this. When you put the calculator, you type this, you see the answer. Now then I have to solve this value using this particular, solve this question using this particular value. So how do you go about it? Now let's, for instance, they said you should evaluate evaluate without using table. They said you should evaluate. Oh, sorry for this. Let me clean this off. Okay. Can't start this today with this now. Come on. Come on. Okay, let me pick this up. Okay, now. So let's start work. Now, as I said, you evaluate without using table. You are given log 6. So how do you evaluate this? Now, you can apply the laws of logarithm. This thing can become log. If you have ordinary log, it means it's 10. Just know that it is what it is 10. It's natural log, it is 10. Now, how can I make 6 to have one of this particular number? If I say 3 times 2 is 6, right? So I can say 3 times log 10 2. Because when I bring this thing together, this log 10 is this, what is there? It's just an invisible 10 here. You know, laws of logarithm, 3 times 2 is still what is still 6. Now, you know, laws of logarithm times is what is plus. So it means your final answer here is log 10 3 is what? When you check this, there is what? 0.477. Then plus, you're not going to multiply. Log 10 2 is what? When you check here, it is what? 0.3010. So when you add them up together, 0.477 plus 0.3010, so you get 0.0778. So that is the answer you get. So this is the final answer. Let's look at another one. Let's say you are given log 42. Log 42. So how do you make this? No, 42 is 7 times 6, and 6 is 2 times 3. So you can rewrite this thing as saying log 7 times log 3 times log what? Log 2. Note that this thing is just 10, no problem. So log 7, when you check log 7, it is what? 0.8451, right? Plus log 3, when you check log 3 here is what? 0.477 plus, when you check log 2 is 0.3010. So when you add them up together, let me scroll this thing down. I think it's already down. So when you add them up together, you have 0.8451 plus 0.477 plus 0.3010. You can use a calculator. You get, your answer is 1.6231. So that is that for this one. Now let's now move on. I'm just going to look at just some simple question again, then we end this particular work. Now let me move this thing up so that it can provide space for us. Now let's look at this. What if you are given something like this? This is more tricky now. You have log, I gave you log 280 minus log what? Log 15. Now it becomes problem. Now you want to look at this. How do you go about this now? If I were you, this log 280, how do I multiply numbers here to give me 280? You know, if I multiply, 7 goes in 28, is 7 goes to 280 is 40, and I can say 5 times 8 is 40, right? So I get that now. So it means this one I can say it like this: log 7 times log what? Log 5 times log 2 raised to the power of 3, because 2 raised to the power of 3 is what? Is 8. Is that also 8 times 5 is 40. 40 times 7 is what? 280. I've gotten this. Then you know log 15. Log 15 is what? 5 times 3, right? 5 times log what? Log 3. This is what this thing will give now. So let's now look at this. Let's solve this one after the other. Let's look at this. I'm going to clean what's at the bottom so that we can have enough space for, this is the last one. We can have enough space for us to go about this. Let me just clean out this one here. Let me clean it off. Sorry for the delay. I have to just clean it. Okay, now this is beautiful. Now let's go back to our question. Okay, this is what we have. Now let's now go. So log I can write this thing as saying, I just want you to understand this. Log what? Log 7 times log what? Log 5 times this 3 can come to the front according to our laws of logarithm. So we have 3 here. Log what? Log 2 minus log what? Log what? Log 5 times log what? Log 3. Now using this now, log 7 in our question, log 7, when you check log 7 based on what is up here, log 7 is 0.8451. That is 0.8451 times is plus, so this will be plus. Log 5 is what? Log 5 is what? 0.699 plus, no, this one will be 3 times log 2. That is 3 times log 2 is what? 0. What? 0.3010. 0.3010. Then you have minus there. Log 5 is what? What is log 5? Log 5 is what? 0.699. Times is what? Is plus, Abi. You write plus. Log 3 is what? 0.477. Right? So now come down now. So when I do this one now, I have 0. This will give me 3 times 3 times 0.3010. That will give me 0.9030. So 0.9030 plus 0.699 plus 0.8451. So I've got this one here is 2.4471 minus, let me add this and this together. So you have 0.699 plus 0.477. So that is 1 point, this is what? 1.176. So when you subtract this, so what do we have? We have 2.4471 minus 1.176. So your answer here is what? 1.2711. So this is your final answer. So that is the end for this. Now we move, then we look at what the next in our next chapter. Bye bye. Please subscribe to my channel and refer your friend.